In this lecture, we're going to explore the situation when we are setting up a class, but it has member variables of other types. So it's basically going to be different from what we had in the last lecture, where we had member variables of the same class while we are trying to declare the same class. So here is a class we're going to use. It's called integer. It's basically going to be a wrapper on an int type, and it's going to have a bunch of values. The constructors, we have the destructor here, and we have a getter and a setter that we can use to manipulate the value that we are wrapping around here. Nothing complicated here. But we're going to be setting up member variables of integer type in our point class. And here we're going to basically try and simulate what we had in the last lecture. Here we have a member variable of integer type, our integer class. We have a const member variable. You're going to see that this is going to work. We have an inline static variable. We can set this up. It's going to work. We can initialize that here because it is inline. You already know this. We can have a const static member variable of integer type, and we can initialize that in here. This is also going to work. You see that the limitations we had in the last lecture don't apply because the member variable is basically different from the class that we are trying to set up here. I want you to be aware of this. Another point which is going to be very different is if we try to use a pointer member variable like we are doing here. We initialize this to null pointer, but if we hit the implementation, you're going to see that now we don't have to go through a function to set up new memory and allocate that on the heap. We can do this directly in the initializer list, and this is going to work because we're not trying to call the constructor multiple times. It is going to be a point constructor calling an integer constructor, so we're not going to have that chain of the constructor calling itself like we had in the last lecture, and this is going to work just fine. We're not going to crash our program. If we go down, we see that we can create a static integer member variable. This is going to work. We can even make that const. This is going to work. But because these static member variables are not in line, we're going to have to initialize them in the CPP file. You have to remember that. So if we go in our CPP file, we're going to see that we are initializing i6 and i7 and putting values inside. And this is really all. If the member variable is not of the same class that you are declaring, you are free to use many things as you want, and it is going to work. Now that you know this, we're going to head over to Visual Studio Code and play with this a little more. Okay, here we are in our working folder. The current project is member variables of other types. We are going to grab our template files and use them here. So we're going to put them in place. Okay, here we are in our working folder. The current project is member variables of other types. We're going to grab our template files and we're going to put them in place. Let's do that. And we're going to open this in Visual Studio Code by dragging and dropping here. This is going to open our project, and we're going to create the classes that we want to use. We want to use the point class and the integer class. So let's create the integer class first. We're going to say integer.h for the header, and we're going to say integer.cpp for the implementation file. I am going to grab the code for integer.h and put that in here. We have our include guard, we have the class declaration. Inside we have our member variable, which is inner int. And we are basically wrapping around this int through this integer class, which is our own custom class here. We are also going to put in the implementation for the class, and in the implementation file, we're going to have our constructor and destructor. This is nothing you don't know yet. We're going to just close this class here because it is already defined, and we're going to create our point class. We're going to create a point.h class header file, I should say, and we're going to do the implementation file, which is going to be point.cpp. And we are going to put in the header file. Let's do that. And again, it is nothing you haven't seen before. We have our include guard. Inside, we have the declaration for the class point. We have our good old member variables, mx and my. We have the point count static variable. But what we really want to see are these member variables of integer type. we can use all these syntaxes here, and this is going to work. Unlike what we had in the last lecture, where the member variables were of point type, basically creating incomplete type compiler errors if we use syntaxes like this here. But in this case, it is working because the member variable type is different from the class type here. Okay, this is then, we're going to put in the implementation part. And here it is basically what you already know. The main difference is that now, because integers 6 and 7 are static and they are not in line, we will have to initialize them in the CPP file. And that's what we do here. Another main difference for you to see is that if we use a pointer, we can initialize this directly as null pointer. This is going to work. But if we go in the CPP file, now we have the option to initialize this directly without going through some member function like we did in the last lecture. The reason is, again, we don't have a situation in which the constructor for point is going to call itself repeatedly. The types are different, so here point is going to call the constructor for integer, and this is going to work. We're not going to have any problem. Okay, now that we have this set up, we can head over in the main CPP file. We can clean it up a little bit and remove what we don't need. We're going to include our point class. Let's do that. We're going to include that. And we can go in the main function and do all kinds of crazy things. For example, we're going to put in a piece of code which is going to try the point class a little bit. We're going to set up a point object. We can print the distance. We can get the points that we have in here. For example, we can access I1, I2, I3, I4. If we try to set the value for I1 and I2, we're going to get a compiler error. If we try to set up I1, this is going to work because I1 is not const. If we go in, we're going to see that it is not const here. But if we go in main and try to change I2, let's go back, I2 is const. If we're trying to change that, we're going to get a compiler error. Let's try to use this. We're going to see that we're going to get a squiggly line. This is going to give us a compiler error. Let's build and you're going to see that. Okay, we have a compiler error and we are trying to call, and we're going to get our compiler error build finished with errors. And the problem is that we are trying to modify something that is const. So we get to this error here that we are trying to use this pointer to modify something that is const, and this is not going to be allowed. Okay, so this is the compiler error. We can go down and access the 0.5, and you remember that this was a pointer, but we're going to get the value inside and use that. This is going to work. We can access 0.6 and 7, and we're going to get all these values here. This is going to work just fine. If we're trying to set the value for I6, so let's go back and see what I6 is. It is a non-const integer, so this is going to work. But if we try to do the same for I7, we're going to get a compiler error because I7 is const, and we can see that here. Okay, so once we do all these things, we're going to end our test, and things are going to work exactly like we expect. Let's build again. We shouldn't get any compiler error now. The build is good. We can clear and run Rooster, and we're going to get our data in our output terminal. This is really all I wanted you to see in this lecture, that you can set up things like this. Please try to go through this and really make sense of what you see here. You can even try and set up your own variables and really try and break things. That's how we learn. We are going to stop here in this lecture. In the next one, we're going to try and learn about static member functions. Go ahead and finish up here and meet me there.